Assalamualaikum warahmatullahi wabarakatuh. Good morning or good afternoon, everyone. I will say thank you for coming in my presentation. Before we begin, let me introduce myself. My name is Jihan Putri. Today, I'm going to be talking about study of the utilization of linear spectral mixture analysis in Sentinel-2A for estimating tea productivity in Malabar Tea Plain Station. I have divided my presentation into four main parts. First, introduction. Second, literature review. Third, methodology of the research. And fourth, schedule of the research. So let's get started with introduction. First of all, I will talk about background research. The tea plant Camellia sinensis comes from subtropical area. The growth conditions for tea plant are climate, soil, and altitude. The tea plant Camellia sinensis is one of Indonesia's agricultural products that can increase the country foreign exchange in this agricultural sector. As you can see on this table, in 2018, the export volume was 49,038 tons, and there was another decline again in 2019 of 42,811 tons. The growth rate of the export volume will continue to decline. To avoid slight losses, it is necessary to estimate production management. Why tea plant production estimate is important? Tea plant production estimates serve to estimate the amount of tea crop production and can assist plantation manager to determine estimate of financing, income, and marketing. Production estimation carried out conventionally requires a lot of time and money, so remote sensing methods are used to minimize cost and time. However, the remote sensing method is also not free from weakness. One of the problems is mixed pixel. Therefore, in addition to knowing the estimated production, the study aims to compare the classification method between linear spectral mixture analysis and maximum likelihood classification to determine which classification method is best used. Now, let's move to my next topic, area of research. This research was conducted in Malabar Plain Station. Malabar Plain Station is located in Kecamatan Pangalengan, Kabupaten Bandung. Altitude 1500 to 1550 meters above sea level. Soil type consists of undersoil, insect soil, and algae soil. Annual rainfall 2,300 to 3,200 millimeters. Daily temperature 20 to 26 Celsius. Take a look at this table. The Malabar Plain Station has an area 1,273.99 hectares, consisting of Delhi, North Malabar, South Malabar, Sukaratu, and Tanara, with 106 blocks. Moving on to research question. Questions on this research include: first, result of estimation tissue production in Malabar Plain Station using linear spectral mixture analysis. Second, difference in the classification result of the linear spectral mixture analysis and maximum likelihood. Third, accuracy value of the estimate result of tissue linear spectral mixture analysis. Next, I will explain to you about the scope of the research. In this research location in Malabar Plain Station, method use, linear spectral mixture analysis and maximum likelihood classification. Data use, Sentinel-2A, and then index vegetation use, NDVI, normalized different vegetation index. Why I use NDVI as the vegetation index? Because NDVI is the best vegetation index to detect vegetation. NDVI can display parameters related to vegetation such as green leaf biomass, area of green foliage value that can be used as a reference of vegetation barriers. Literature review is the second part of the presentation. This table clearly shows the reference of research is: first, utilization of Sentinel-2A in estimating tea shoot production in parts of Karanganyar Agency. Second, Linear spectral measure analysis of spot 7 for T-yield estimation in Penginderaan Estate Batang, Central Java. Let's turn now to Sentinel-2. Why I chose to use Sentinel-2 for research? Because Sentinel-2 can be used for area observation of vegetation, forests, agriculture, plant stations, and fields. And Sentinel-2 has a median spatial resolution for band 2348 by 10 meters. In addition, Sentinel-2 can be accessed free of charge. Sentinel-2 image satellite used in this research. The following is an explanation. Have two constellations, Sentinel-2A and Sentinel-2B. Sentinel-2A and Sentinel-2B. The satellite orbit altitude of 786 kilometers. Sentinel-2 was first launched in 2015, and then the temporal resolution for Sentinel-2 is 10 days for one satellite and 5 days for two satellites. Moving on this slide, maximum likelihood. Maximum likelihood classification is an algorithm that utilizes the use of quantitative evaluation method of variance and correlation of spectral response patterns. Let's move to mixed pixel. Mixed pixels are a problem during the land cover classification process where there are several objects in one pixel, so that the pixel value becomes impure. Mixed pixel will cause errors when the vegetation in this process is used in vegetation land cover research. Moving on, LSMA. Linear spectral measure analysis is a linear spectral separation model on the basis that the spectral reflectance of the object being observed in a linear measure of all pure spectra. This is a LSMA formula. As you can see on this picture, example, the end member consists of water, bed soil, and vegetation. The terms of the end member are the number of end member is equal 1. And then each number value has a value of more than 0 and less than 1 respectively. Advantage LSMA is produce information down to subpixel level. The third part of this presentation is methodology of the research. In this study, the data used Sentinel-2A, map of RBI Kabupaten Bandung, Malabati Plain Station, shape file of Malabati Plain Station, and T-production data in Malabati Plain Station. And use tools, hardware, laptop, camera, software, Microsoft Word, ArcGIS, NV, QGIS, and Microsoft Office, Microsoft Excel. Let's move to flowchart. I will explain flowchart in this research. First to do in this research is to collect secondary data consisting field data and land cover. Field data and land cover. The satellite used in this research is Sentinel-2A. Sentinel-2A processing consists of radiometric correction to improve image display quality, correct the pixel value, and visual image improvement. The next step is geometric correction. Geometric correction to restoration or rectification, registration of position, and transformation of image coordinate system to map or register image to map. The RBI map used to determine coordinate in the geometric correction process. The next step is image cropping. The output in this process is crop Sentinel-2A corrected. Furthermore, a supervised classification process is carried using maximum likelihood classification. The maximum likelihood is identifying land cover. Another classification is linear spectral measure analysis. Another classification method used in the LSMA, the stage of LSMA method are MNF transformation and member determination to determine the type of land cover, and a member determination to determine the type of land cover. Example, and member is soil, tea, shadow, and tree and water. After the maximum likelihood classification and LSM classification process is complete, a classification comparison analysis carried out to determine the best classification method used metric confusion matrix. For example, in this research using sample for regression and sample for validation. Then the regression process was carried out between the tea production of PTP and egg Malabar plantation with the result of NDVI, maximum likelihood, and LSM classification. The result of this process is two regression. First, regression for NDVI use LSM method with production tea in Malabar. Second, regression for NDVI use maximum likelihood classification with production tea in Malabar. Two regression can be used to estimation model and produce the production estimation map. Then the last step in the flowchart is validation. Validation use independent sample and production tea Malabar. Validation used to find out difference between the production with remote sensing method and the tea production data in the field. Data field. The fourth part in this presentation research is schedule research. And this is my research schedule start from February to July. And this is a bibliography in this research. Okay, so that brings me to the end of my presentation. Thank you for your attention and listening. Wassalamualaikum warahmatullahi wabarakatuh.